World here, December 12th, 2019. And we're going to talk about the sun here real quick. We're having some more CMEs, guys. I wasn't really expecting this amount, but we are seeing quite a bit of action going on. My point here, guys, is that just because there is no sunspots does not mean that the sun is inactive. Because right now, most certainly, it is not. Most people tend to say, hey, there's no sunspots, so the sun's not active at all. That's not what's going on, okay? I just have to put that out there like that because it's just the truth. Now, as you can see here, I got you over at spaceweather.com, and this right here is just their front page article today. We're 3 days away from breaking a space age record of days without sunspots for the year. So that right there tells you that we're in a minimum, okay? Not to mention that this is actually a deeper minimum than what we have experienced in the space age, okay? Because that's really what they go off of. They go off of sunspots that are Earth viewing. We can see it on the sun from our view, okay? That's how they base this, pretty much. I mean, that's pretty much the biggest stat that they use. So, what does that mean? Well, frankly, it doesn't really mean a whole lot because we're already there. We've been experiencing this already. It's a data point that we can point to for historical reasons and to judge what we're going to be seeing in the future. Okay? That's why this makes any kind of a difference. So what I'm going to do here is show you, if we get 3 more days within the rest of the month here, we're going to break that record. So I can guarantee you that that's going to happen. How much we break it, that's to be seen. So, whatever there. But before we move on to that, it's talking here about the Gemini meteor shower on the 13th to 14th of December here. That's something we experience every year, okay? But this year it's not going to be as visible because the sun's going to, not the sun, the moon's going to be full. So the moonlight's going to kind of drown out what we can see. So it's going to be, in some areas, it's going to be kind of hard to see these small little fireballs from this meteor shower. But it is going to be happening. So if you guys want to go over to Live Meteor and check it out on that site on YouTube, they do the live update, the live stream where they show you meteors. They put sound to it and all that kind of a thing. There's a couple different. I've shown those sites before. So that's probably what I'll do. I'll check it out there just to see what's going on with that. But here's the chart. I've showed you guys this before. 2019. I took this about a week or so ago. 2019, 259 days. Right now we're sitting at 266. So these numbers have changed a little bit. At least the 2019 number has. Now, if you notice back in 2014, okay, we had 1 day. That's it for the whole year with no sunspots. Okay, so you can tell that that's a maximum, right? You can see the actual sun cycle going from maximum to minimum and back down again. Well, minimum to maximum, back down again to minimum, where we're at now. See that? So, I'll show you this, okay? Now, this right here is a picture of our sun from the same satellite, exactly 5 years apart. The one on the right is the sun that we have now. The one on the left is back in 2014. Now, I know that looks drastically different, and it should, because you see all the sunspots, right? That's the difference between the solar maximum and the solar minimum. Okay, that is the swing that we see. Now, the danger that we see right now is because we're in we're breaking these records, right, of no sunspots. So what happens is we're not getting that solar wind and stuff from the sun as much, the energy from the sunspots and stuff as much. So it's weakened our shields themselves. Okay, so we can't defend off cosmic rays as well, all the stuff that comes along with that. Plus, we can't defend off even stuff coming from the sun as well, like CMEs and solar flares. Because let me tell you this right now, just because the sun looks like this does not mean that we can't have CMEs. CMEs can blow anytime they want. So can solar flares. You don't have to have a sunspot for any of that. That's the danger that we talk about. Because over here on the right, we're weak. So say today it blows a CME right at the earth, our shields are weaker. So it's going to hit us harder. 5 years ago, if the same CME blew off the same direction, we probably would be able to fend it off a little bit easier. Okay? That's my point. So, but anyway, I just wanted to show you guys that. So I'm going to show you guys some CMEs that's been going on, okay? Okay, guys. I got you over here at seeds, okay? I'm going to take you back to the 9th. I showed you guys this yesterday, but I'm just running through this real quick so you guys can see the history of this. Now, you can see on the 9th we had 2 CMEs. Okay? You can see the one, obviously, here. You see the one here that started, right? So that's 2 right there on the 9th. Now, the one on the 10th is just an extension of the one on the 9th. So it's the same one. Okay? It's just the back end of it. But, look here. See that? Okay? That's the start of another CME. So I was waiting for that data to come in. And it's in. And yes, we did. We had another CME. Okay? So that's 3. 3 in 3 days. Alright? Now, remember what I said about yesterday in my video about how we see these CMEs pop off and then we see a smaller one over here. 180 degrees difference. Okay? Kind of basically on the other side. Now, we're seeing that again. Now, we don't have any seeds data for the 12th yet. Okay? But I'm going to take you guys over to SDO and show you that, in fact, on the 12th, we're going to see it tomorrow on the seeds probably when this updates. There's another CME right there. And the why that one probably happened is because of this one started first, and then again, that 180 thing I've been talking about over here. Because it's exactly what happened. So what I'm going to do is I'll run these back through here again. That way you guys can see it real quick. That's the one from yesterday. All right, so this is when it started. This is the 9th. I just want you guys to see this, get a good look at it. All right, there it goes, it starts. There it is. This is the 10th. It's one I went over yesterday. And then here's the one today. Okay? What you're seeing over here on the right here is just the back end of that one from the 10th. Okay? Now, again, this one over here, I mean, these are sizable, guys. These aren't, just little puffs. These are filaments that are releasing, and these are true CMEs. So, I'll take you guys over to SDO and show you the next one. So, it's going to be 4 CMEs basically in 4 days is what I'm saying. Okay, guys, I got you over at ISWA. This is SDO. What we're going to look at, guys, is this other CME that's starting that we can't see on seed yet because the information isn't there yet. But it's there, okay? The CME is happening right there. I want you guys to look at that. I'm going to go ahead and start this up. Okay, we'll just zoom in here. You're going to see this. This is what it looks like, kind of what we would call slow motion, I guess, if you want to say that. But this is a filament that's releasing. All right, sometimes these get sucked back to the sun, and most of the time, some of it always gets sucked back to the sun, but some of it also gets pushed out into space, which becomes the CME part. Okay? So as you can see, that's leaving the sun. Okay? So that is going to probably show up tomorrow on the seeds as a CME. And it seems to be like this one may be moving slower than the others. I'm not sure. I mean, I can do this if you guys want to watch up there. You can kind of see the motion of it. And as you can see, if you look over here, down here, you can actually see the tail end of the last CME. See that? So, I mean, there may even be some more ejections coming off of that side. So, okay, here's what I want to say about this. Okay? And when we look at these satellite captures, like what this is giving us, we're able to see these things on the edges, if you guys have ever noticed. All right? They're much easier to see because you got that black background where the sun's not. But let me assure you guys that stuff is happening here too. It's not just going to happen on the edges. Let's not forget that, okay? Because we just can't see it as well. It's not as visual. Now, you know, we can go look at stereo A, but stereo A is highly pixelated. It's really hard to get a good capture of anything that's going on stereo A until it gets shot out into space, and it's still pixelated. So that's why we don't go to that one very often. We always go to it every time we see something just to figure out direction. But you can't really like pinpoint and show people, you know, detail at all on that particular satellite, because that is not at all good good camera stuff. Okay, yes, it's good enough to do what it needs to do, but for this purpose of showing you guys, this is much better. Okay, but anyway, just keep in mind that just because we always see the stuff on the sides, the reason being is because there's a black background of space. So we're looking directly at the sun here, and we don't get to see these umbras and the active areas as easy, or the filaments dancing around as easy, if they're on the surface facing us. So I just wanted to point that out too. So what does that all mean today on this video? Well, all that means is that we've had 4 CMEs in 4 days. That's it's pretty active if you ask me. You know, obviously we're not seeing any sunspots, but that doesn't mean that the sun isn't doing anything. Matter of fact, they can actually be more dangerous, like I explained. If there was a CME Earth facing right now, the lack of sunspots that we've had has weakened our magnetic field, so it would hit us harder. And again, I guess what I could do here real quick is show you that sunspot. I mean that coronal hole too. We'll just look at this real quick. Now this is a sizable one, guys. This one isn't small, and it's actually pretty deep. See how dark that is? Okay. Again, I always say this: the equator's here of the sun. The Earth kind of sits here. All right, kind of just to the south of the equator. So we will connect to this thing, and we will get solar wind from it. Now, here as of late, the solar wind streams seem to be weaker than what they normally have been in the past. So, in other words, we're not getting the hit from them that you would typically expect. And the main reason for that is probably the density of it isn't as high. Not really sure exactly what's going on there. But that's just been the past month or so we've noticed that. I'm not sure if that trend will continue or not. But, you know, if you've noticed some of the, even I would go to some of these reports and stuff, and I would tell you guys, hey, you know, look for bigger auroras. You know, hey, we might see a geomagnetic storm, and it ends up being that never comes to fruition because the stream was weaker than what they thought. So we always got to keep that in mind. And I always say that anyway. You know, we don't really know until it gets to our detectors. So we can just kind of guess, do our best guess at it. And most of the time, just by using historic data, we get pretty close. But I just wanted to point that out. So yeah, guys, I'll come at you guys tomorrow with probably another video. So God bless. And yeah, this is Wage's World, where truth is sought and fear does not exist.